The universe travels the path of entropy. The only way forward is chaos. What is up, YouTube, and welcome back to episode 3 of the Draco RC build. Holy crap, we've got a lot done. We've got so much to go over. A lot of it is off-camera, stuff that I didn't record. A lot of it is stuff that's complicated shapes, complicated things that I have to try multiple ways until I get it right. So it's not something I really record because I do something for like 4 hours and then I throw it away. I start from scratch again because that 4 hours was just me figuring out a way to do something and then realizing there's a different way to do it and then having to start again. So it's not really interesting to watch. It's not something I record, but I'll go over what I have done. I do have some stuff recorded from earlier on. We got the prop done. A form of the prop. I just wanted to do some sim testing. I spoke about this in a previous episode. We'll go over that in some more detail. We also got the rear elevator and rear horizontal stabilizer done. We have the startings of the tail section, and we have the startings of the fuselage. I will go over why it's just the startings and not like an actual thing yet. There's a bit more to it. It's a bit complicated. We'll go over it. So let's get straight into it. First things first, get some reference, get it into the scene. Just get some scale, some points. In one of his videos during the build series for Draco, he mentioned that he's using a 104-inch prop, which is slightly larger than the 102-inch prop that comes standard with the Draco. So I know that I have the prop size, and I know how big I want to make the spinner hub, which is roughly 70, 80 millimeters-ish. It'll get better defined as we get further along in the project, when we can decide how the mechanisms and everything are going to work. But to start off with, just getting the reference in there, getting the length of the prop, and then looking at the prop from as many angles as I can to look at the shape and geometry of it. So here I'm just putting in the very first profile. It looks like a funny shape. So props for variable pitch props have slightly different aerofoils to regular props. Regular props are designed to have a certain pitch or a certain screw angle. This gives it a certain angle of attack when it is spinning around, and it gives it a certain amount of, for every revolution, if we're moving through a perfect medium, like instead of air, for every bit that it cut through, it actually progressed that distance, based on its pitch, its spiral pattern that it creates, then that will work. But a variable pitch prop, because it is a variable pitch, it needs to stay at a constant RPM to deliver different thrusts based on its angle of attack. So the shape of them is a little less aerofoily and a bit more like flattish. It has a slight aerofoil curve to it, but for the most part it is just a flat blade that goes flappy when it's straight, when it's in beta mode, and it can turn and give you your reversed and forward thrust. So yeah, just going through creating just basic profiles. This isn't like the final form of it. Like you can see that center one is a bit weird. It's like got a bit of an S shape to it. I was just mocking this up quickly to get the basic shape as close as I can so that I could run some simulations. So after creating the shape, the right size, I'm looking here, okay, where can I put in cavities to put carbon fiber rods to give it some more strength? Because I'm pretty sure I'm gonna have to give it a little bit more strength, a bit more, composite to it. But yeah, it might not need it. So there I got the weight of the blade. This was the key thing. So Inventor allows you to apply a materials property, and then you can look at the eye properties and it tells you the weight based on the volume and size of it. So that tells you how much it weighs. Then by going and doing a bit of Google searching, a couple of YouTube videos later, I find the mathematical formula for working out centrifugal force. And from that, I can then make a spreadsheet, work out my RPMs, because I work out what RPM range I want. And from that, I now have how many newtons of force the blade will be under at a certain RPM. From that, I can transfer those newtons back into Inventor and run a sim test. And with the sim test, I can figure out if it's going to explode or not. Turns out it's not going to explode, and that's even without the carbon fiber reinforcing in it. So we're all good. So let's move on to the next thing, the tail section. This was interesting. This is one of the ones that I've done a couple of times now. This that I recorded is the first time I did it. Nothing really changed from the second iterations of this. The dimensions and the method I use for making the core structure, which is this cone shape, which is the tail itself, the spine. From this, I got dimensions of this. Okay, I've got a part file that I've got in the folder with all the parts for this. And in this part file are just loads of pictures of the Draco stretched out to the right dimension for a certain individual thing and another thing that I can match the size of in another photo so that I can translate the dimensions from that image that I've stretched and scaled to the next one that I've stretched and scaled, so that I can get this one dimension on this one part that I can't get an accurate dimension of in the first photo because it's either not in the photo or the photo is at a certain angle that the perspective of it has changed and I can't get the dimension. So it's really crazy. It's like that meme of the board with all the strings and that but in 3D, right? Okay, it's been a bit crazy, but I'm getting through it. So I made the cone that goes from the fuselage section down to the tip of the tail. And now I'm creating the spine, the ridge that goes on the top of it. And all that is a semicircle with a box at the front and another semicircle with a longer box that flares out at the bottom in the middle. And I stop it there. So next up, I need to make another loft, which goes from the inside of the end of the cone out to the top of the vertical stabilizer. And this gives me the airfoil shape for the vertical stabilizer. But it sort of swoops from the vertical section through to that spine. And in order to do that, I have to make this slope that goes up, which is the vertical stabilizer. Then I have to create a sketch on the side of it, or in the center, and extrude and cut off the front of it. So I get a flat face at the front. From that flat face, I then loft between that face and the spine that I made before, which gives me the swoop. And that's how you create that shape. Doing stuff like this, where you're using lofting functions in multiple directions to get the shapes that you want, is basically what I've spent the last 3-4 days working on. That's it. So, what else have we got? We have the horizontal stabilizer. I only got footage of the horizontal, like the horizontal stabilizer. I didn't get footage of me making the elevator, the flappy bit. Don't know. I think I forgot. Don't ask me why. I think I forgot. That's the excuse I'm going with. So, once again, reference material. I'm going to keep saying this. Reference material. You just, when you're doing a project like this and you want to be accurate to something, you have to go through so much reference material. It's not even funny. You're going to get sick of looking at the same pictures over and over and over, just hoping you'll spot one tiny detail you didn't notice before. And yeah, so like there was lots that I learned from the rear section plane from these images from doing this. So first up, we're making the horizontal stabilizer. This is a bit that doesn't move, it's a bit stay still. I need to find out what the airfoil for it is, what the chord is. Just looking at a couple of different pictures, trying to get like how skinny is it at the front, how fat is it in the middle, does it go straight, does it slope, like what does it do? So we're gonna find out, get the profile, extrude it, real simple. Now we just look at how everything connects. It looks like there's a tab that comes out the front of it that goes into the spine, the back of the spine of the vertical stabilizer. There is a tab that comes out the back. That is for the elevator. It is a centralized hinge. It is a displaced centralized hinge. So the hinge is outside of the fixed body and in line with the fixed body. It's not an upper or lower hinge. So there's a tab in the middle and there's two tabs on the outside. Now it's a very interesting elevator because it has bits on the ends that are, I forget the name of it, it's the same thing as counterweights, but it's a counterfoil. So basically it's an airfoil that hangs forward of the pivot point so that when you are applying pressure, the airflow going over it allows it to balance out the forces against the airflow at the back of it. So you're not having to put as much force into your controls to get it to move. So a bit of the airflow does the work for you as well. So it balances out. Yeah, I think it's called a counterfoil. Yeah, it looks like a counterbalance, but it's for airfoils. Putting in the lower connection, so there's a tab that comes out the front that connects the stabilizer to the back of the vertical stabilizer, and then there's one at the bottom that connects it to the back end of the tail, so it sort of sits on there. Now I'm going to put a little mechanism in the back of the tail there that I can adjust, so I can change the angle of the horizontal stabilizer, like its trim basically, to the rest of it, because once I've built this, depending on the weight and stuff, instead of having to move weight and things around or having to change the trim in the settings for the servos, I can just adjust the whole thing, and that will change just a few degrees. Makes the world of difference. I think that's going to be very important to have that built into it as a mechanical function that you just set and forget and it stays the same until you change something else in the airplane. Now I'm just adding the tabs on the outsides. These are cross braces, so they create triangular trusses between the center of the aircraft outward to stop it from going side to side like this. Only working on the one side of the aircraft because I can use a mirror function to do everything I do on one side on the other side, so I don't have to do stuff twice. Being lazy is your friend. You work extra hard to be more lazy. That is the secret to doing this sort of stuff that I do. You be as lazy as possible, and you will learn all the tricks really fast. By really fast, I mean years and years of dedicated work, but we will just brush over that. Placed in the points there for some spars, so that we have a carbon fiber spar running through it, so we're not relying on the strength of the resin only. We also have some real strength carbon fiber. Yeah, carbon fiber is so strong. I love it. Yeah. So this is where we're at the moment. As you can see, there is a fuselage section there. I don't have any footage to show you of working on this. This was interesting, to say the least. Let's have a look at it. So it's a bit transparent there. Let's just give it a materials override. Smooth, red. We'll just go default gray. Default gray. There we go. Right. There you can see it. It's a very interesting shape. So from what I've seen in the balsa plans, and all the other plans that I've seen online, or anything online that isn't the actual plane, no one has got this section of the plane right. No one has got this shape right. I have not got this shape right yet. I'm working on it. I'm very close. This is a very interesting shape. Let us have a look at how it is created. So we come in here just before I started combining stuff. So this is before I put the airfoil section on for the root of the wing. This thing is made up of, and let's count them now. 1, which is the window section. 2, which is the head of the root of the wing root. 3, which is the loft between the wing section and the head of the wing root. 4, this is the majority of the body. It has quite a large flat face on the side, but it is not a straight angle. It is at a 5-degree angle. So if we come in from the front, you can see it more clearly. It has a bit of a sweep to it, a straight line. Right? This whole section here is pretty much flat, so I just extruded this out and then used another extrude function to cut it at that angle, so it creates that angle. Right? What are we up to? 1, 2, 3, 4, 5. 5 was an interesting shape. So what this is, this was a loft from the back of number 2 to the shape that I created off the back of number 4. Yeah. So on the back of here, I created a sketch plane and I created this shape, but it didn't include this line here. It came sort of straight up. So I created a loft from the back here to here, which gives me this curve here and this curve here. But the problem is it came out too far here, and it turns out that the side back edge of this plane has these two flat faces under the wing, and they're very difficult to see. You have to really look for them. Where is the image that I have? So in this image, it's a little difficult to see, but you can clearly see that this is pretty much a flat face here. You can tell by this shadow. If this was a curved face, this shadow would have a different shape to it compared to the line that it's being projected from. Also, you can tell by the lighting, it's difficult to see, but a lot of the mottled lighting in that face is pretty flat. You don't get these lights, if it were a curved surface, you'd see more of these lines. These lines are created from light, refracting off of a curved surface. It's more of a flat mottled sort of shape, so that tells me that is a flat surface. I also know that this is a flat surface in here, and there seems to be a hard line there. Looking at another photo, this one here. This one's a little bit more blurry, but this one you can see it a lot more clearly. There is a hard, distinct line here, going back, creating a triangle shape. We have another triangle shape in here, and another triangle shape that looks like from here. So this surface here is not the same as the flat surface here of the door. And this surface here is the dihedral angle of the wing, because if you continued this surface up, it would meet up with this point here on that line. So looking at these reference images, trying to get this curve here plus these flat faces was a nightmare. Coming in and having to create the curved surface first, and then creating multiple extrude functions. These ones here. So this one cut away the dihedral face, and then this one cut away that angular face there. So and then to top it off, I then had to do another loft function that trimmed, because this was a straight line continuing from this curve that came out to about here with the mouse is. I needed this to have a bit more of a curve in it. So if we look in this loft function, you can see the sketch that I had to create this compound curve on the roof of the aircraft here. It's such a strange shape. It's very complicated. It took me hours to figure this out, and I'm so happy with the results. This is the closest shape to the Wilga, to Mike Patey's Draco, that I've seen anywhere. Every balsa plan that I've got or found doesn't even come close to this. So this is much better. Things I'm not happy with that can still be better. For starters, I'm unable to shell this shape. If I grab this shape and go to 3D model, I can't use this shell tool to make it hollow so that I can remove all the weight and do all the other bits inside that I need to do. I'm going to have to do that manually. The other things I need to change, this isn't a perfect, well, it is here, but it's not supposed to be. This is supposed to be a little bit shallower in this axis, so I need to make that shape. But the way that I've made this thing, and this is going to blow your mind, this is the sketch that I used to create all of these wacky shapes. This is a 3-dimensional sketch that gives me all the dimensions and shapes that I need to work stuff out. So there's still lots to do. I still want to do the front cowling, the bit that comes off the front of the aircraft, so that we have now the overall dimension and shape, and I still need to do the rudder. And once I've got that, all the major parts are done. Then it's just coming in and doing all the detail work, getting all the surfaces detailed with rivets and stuff, and doing all the interior stuff. How does it all fit together? Where do the components go? The receivers, the servos, the motor, everything. I've still got to do the landing gear. Oh my god, that is going to be the hardest part. I'm leaving the landing gear, the main gear, till last. That is going to be so hard to do. So there we have it. Bit of an update for you guys, show you what I've been able to get up to. This video has come out earlier. I was thinking, umming and ahhing, should I do this later next week? So do a video once a week, but I'm like, nah, you guys need more of an update. I'm progressing so far and so quickly that if I did another video next week showing everything I've done, it would be the same as what happened last week, where I did a whole week's worth and then tried to put a video together of that, and there was just too much to edit and go through. So hopefully this works a lot better. I will put out a video whenever I've got enough to put out a video with and to show you this is where we're at. I'm loving the progress so far. It's really looking awesome. I cannot wait the Tesla stock to go up a bit more so I can sell the stock, buy a printer, buy all the other stuff, buy the resin, buy all the things, make this plane, go fly it. I'm so excited, I can't wait. So, hope to see you guys in the next episode. Go check out my Twitter where I post regularly. Go check out FliteTest forums. I have a thread on there where I'm posting regularly, keeping them up to date. If you'd like to support the channel, head it over to my Patreon, check that out. Really helps out a lot. I'll be able to get that printer faster, get the stuff done faster, and do a lot more awesome stuff in the future. So, as always, thanks for watching. I've been Chaos, and until next time, expect the unexpected. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.